In this video, we're going to look at a sample of a medical trial where some people took some medication, and those that used it, there was a certain amount that got some symptoms which were of a negative impact on their health, and some of the people didn't get symptoms. And here we had also a set of people as well who didn't use the medication but still had some symptoms of negative health, but also some people that didn't have the symptoms of negative health. Now what we want to do is, for the purpose of this trial, so our goal is to find the odds ratio to give us the correlation between that, and then a confidence interval, and quite a strong confidence interval, as in the 99%. So we want to be really sure before we can start marketing this drug to see if there's any negative impacts on people's health. So first of all, let's work out the odds ratio. So let's do that. So odds ratio. Now there's a formula for that using this contingency table, and it consists of a fraction. As in a ratio, you're always going to have a fraction involved somewhere. And what you do is we take this top line here, symptoms and used. So I'm going to call that symptoms and used. And then we divide that by no symptoms and used. So I'm just going to call that no symptoms and used. And then our denominator will be the opposite. So symptoms and not used. So I'm just going to call that symptoms and not, and divide that by no symptoms and not. So no symptoms and not. Okay, so all we're going to do now is just plug in our values into our fraction, and it will give us a value. So let's see what happens. So symptoms used, 237. And then we can divide that by 373. So we can see straight away that this is around about 2/3 ish, something like that. Now what about the denominator? So symptoms not is 423, and then divide that by the 497. So again, this is about 0.8. So we're looking at around about 2/3 divided by 0.8. So plug that into our calculator and we get our odds ratio. So I'm just going to call that odds ratio. Then we'll get an approximate value of 0.7465. So it's not an accurate number, but to 4 decimal places, 0.7465. Okay, so that's our first step towards calculating if there's any correlation in this drug and some negative symptoms. Okay, now we want to find a confidence interval. So confidence interval involves this formula. So we need basically an upper and a lower boundary for an interval. That's what a confidence interval is all about. So our odds ratio upper value and our odds ratio lower value, that equals, basically our odds ratio is our first port of call for our calculation, which would be this number, times the exponential function multiplied by, now here we're going to need a value from our quantile range, so we'll call that our Z value, and we're also going to need to calculate our standard error. So we also need a function called the standard error function. So that's our upper bound by using that, and then the lower bound is basically the same as this, but exponential is to the negative term. So our odds ratio multiplied by the exponential function and negative Z and standard error. Okay. So from this formula here, we can see we need to work out our Z value and our standard error. Well, the Z value will come from our normal distribution tables with our quantiles. So we want a 99% confidence interval, but as this would be a two-tailed interval, we want 99.995. So 0.995 is the value on our table. So on our table we want phi of the quantile of 0.995, and if you look on our table, this will give us an approximate value of 2.576. So that's going to be our Z value. And then we want our standard error. So if I write here standard error, Now this is calculated using the square root function. So here we've got our standard error, which is the square root of 1 over all of these numbers in our contingency table. So 1 over 237 plus 1 over 373 plus 1 over 423 plus 1 over 497. Okay, so now we put all those numbers into our calculator and we will get approximately square root of 0.01128, which will give us a value of approximately 0.1062. So that's 4 decimal places. So with our rounding errors, that should give us plenty of room to get a nice accurate confidence interval. Okay, so now what we need to do now is go back to this function here and plug in our values. It's as simple as that. So now we've got upper bound and our lower bound of our interval. So that equals our odds ratio, which is 0.7465. So 0.7465 times e to our z value, which is 2.576. So I'll write this in its indice, and then multiply that by our standard error, which is 0.1062. So that will come to around about 0.26, 0.27, something like that. We'll plug that in the calculator and that will give us our value. And then our lower bound will basically this to the negative exponent. So 0.7465 times e to the negative 2.576 times 0.1062. Okay. Right, so plug these into the calculator and we should get a boundary, an upper and lower boundary of approximately 0.981 and 0.568. So you can put those into your calculators and check to see if I've got it right, but that's what I got earlier when I just checked these figures out. Okay, so that's how we've calculated our odds ratio and our confidence interval. Now we need to draw to some sort of conclusion from these values and these figures with our odds ratio. Now, if you got a score of 1 in our odds ratio, then everything would be independent. So therefore that would say that there is no link at all, or suggesting there's no link at all between the medication and the symptoms. That's only from a statistical point of view. The reality could be different. But here we've got a value here less than 1, and in our confidence interval they're all less than 1. So that would indicate that there is a negative correlation. So if I write that here, so then we can draw the conclusion there is a negative correlation. So our tests here and our statistical analysis is telling us that the medication and the link between that and the symptoms has a negative correlation. So that's the conclusion we've drawn to from our statistical analysis, and then we'll pass that on to our medical experts and they will continue using that in their trials. Okay.